Okay, hello everyone, and welcome back to another PyCrafters recap session. So, every recap session before this, we have been working primarily with HTML and CSS. What we're going to be getting into today might be a little bit more interesting to you if you like this sort of thing. We're actually going to be getting into circuits. So today we're going to be talking about how to design circuits. We're going to be talking about how circuits work, what a circuit is. We're going to be talking about all the components in your Arduino kit, which you should have by now, and we're going to show you how to use them all. And it's pretty much going to be an introduction. Okay, so this is the lecture night, right? Not the application, so there is going to be a lot of me doing this with my mouth. So get ready to set your pencils on fire because you're writing so quickly, because you will need to keep a lot of notes. If you're not keeping notes, you're probably not going to get any of this stuff. Now I should tell you that I will have given you handouts in class for this, so please make sure you have them while you're watching this recap session. If you do not have them, that is okay. You will probably create your own handouts exactly the same way I've created them if you're writing everything down that I tell you about. When I show you a slide and it shows you a circuit component, you're going to want to write down all the connections and write down whether it's positive or negative or whatever all the markings I tell you to write down are. So just keep that in the back of your head as you're watching this. Alright, enough of me gibbering. Let's get into some circuit components and how to work with them. Okay, so what I'd like to quickly do is just pretty much go through what we did in the class, show you the same slides, but obviously I'm going to go through them a little quicker than I did in class because I'm not going to stop and talk about as much, hopefully. If I can stop myself, I'm not going to talk about as much as I did in the class. So if by the end of this you still have questions, comment on this YouTube video, or as always, the Slack chat would be the place to go. Alright, so let's move on to the second portion of the PyCrafters class, which is electronics with the Arduino. So, like I said in class, the biggest idea to wrap your head around and remember, if it's one thing you get, is that a circuit equals a loop. Okay, so when you think the word circuit, you think loop. So if your circuit's not working, think about, is my loop complete? Wire is a tube that electrons will flow through, and we're going to talk about that idea in a second. Okay, so the electrons that I just talked about flow through the wire, but why do they do that? They do this because of a battery, which you can probably guess why they do that. Well, probably not, actually. So the battery is basically a giant magnet, and let's talk about why it's a giant magnet. Probably the easiest way to understand this would be to look at the simple circuit on the right, and you want to imagine that there are two halves of this battery that are split in half and are completely separate from each other. So you have the positive side and the negative side, which are marked there. Now there's absolutely no way for anything that's on the positive side to get over to the negative side unless they go through the wire. So there are positively charged electrons on the left and negatively charged electrons on the right. They really want to be in the same compartment. The positives are attracted to the negatives, but they can only get there by going through the wire, which you can kind of see why now I think of that as a giant magnet, because the negatives are pulling magnetically on the positives. So it's a loop that starts and ends at the battery is the main idea to get here. Okay, so that's the idea behind a battery and the wire and the electrons. Alright, so one of the second most important thing to get out of this class is that first sentence you see there at the top. And usually I have the students repeat this after me because it's so important. Write this down. If it's one of the only things you get on that paper, it needs to be this first sentence. All components on your breadboard must be grounded. If they're not grounded, they're not going to work properly. Grounding is done using resistors, which you can see in the lower right-hand corner of the screen. So the resistors go from the component that you want to ground to the grounded rail on the breadboard. And we're going to talk about the breadboard and what the rails are in a minute. okay? But just know that every single component must be grounded, and that grounding is done with the resistors going from the component to the grounded rail on the breadboard. Okay, so what are these breadboards that we've been talking about? Well, a breadboard is a board, essentially, with holes that are connected in certain ways. So these holes allow you to place components easily in a circuit, and these holes are connected in certain ways that will help you create circuits a lot easier. So, first thing we need to talk about are the rails. So a breadboard has what's called rails, and it has rows. So the rails are those plus and minus things that go all the way up and down the length of the board. So from 1 at the top on the positive side to 30 at the bottom, which is actually, those are the numbers for the rows, so never mind. The rails don't have the numbers. From the top of the positive all the way down to the end of the positive, whichever end you're starting at, all those are going to have that. They're all connected. So if I were to put power anywhere on that positive side, I would get it anywhere else on that positive side. Same on the negative. What I do want to stress is that these are not positive and negative. They are positive and negatively marked. Okay, so they're just marked like that. You can switch it up, but I'd like you to keep the positive for power and the negative for ground. That way we can keep things nice and simple, and we're all doing the same thing. So when I say send 5 volts to the positive rail, positively marked rail, then everybody's going to do that, and you're going to know what I'm talking about. So that's what I just like us to do, is to ground the negative and to power the positive. Okay, so those are rails. The rows, rather than going vertically up and down, they go horizontally left and right. So if I were to apply power to row 1A, I would also get power out on 1A, B, C, D, and E. So all of 5 of those would get power. I would not get power on row 2, A through E. So hopefully you get the difference there, that those 2 rows and all those rows are separated. Okay? And it's the same on the other side of what I like to call the gap. You'll see there's F through J. Those are completely separate from A through E. They're separated by that gap in the middle, and we're going to talk about how we use that gap in a minute. So hopefully now you get the difference between rails and rows. Okay, so now we're going to talk about something that is actually very, very important. We have what's called jumpers. Now jumpers may seem pretty simple at first. They are wires that allow for easy connection between components on a breadboard. Well, they're actually not that simple. And let me hopefully stress this by, give me a quick second if this loads. Here we go, good. Let me write a new note. And what we're going to do with this note is we're going to create 3 different colors. So we have green, red, and orange. Now, what do these mean? Well, when I create circuits, and I'd like you to do this as well, I color code my circuits. Okay? And pretty much I use only these 3 colors. So, there are also 3 other things that we could apply to these potentially. So the 3 things are power, or PWR, ground, or GND, and signal, which is SIG. So those 3 generally we apply to all 3 of these. Okay, so let's see if we can match these up with their appropriate colors. So I usually play a guessing game during class, but since I can't really do that with you now, I'm just going to tell you exactly what they are. So green is G and D. If you've taken the class, I'd like you to try and guess for all 3 of these. So I gave you ground. Now let's see if we can guess red. So go ahead and pause the video, see if you can guess, and test yourself, and then let's see if you're right. Okay, so red is power, PWR. Okay, and orange, oh, it's not big for some reason. Let's see. Here it is. Orange is SIG, or signal. So Those were the three options, and we have successfully paired them. So if you're watching this and you don't have this written down, I would seriously recommend writing what you see here down, because you will need to memorize this. It is on the quiz that you will be taking at the end of this video. So you have green, GND, red, PWR, and orange, SIG, which is signal. So ground, power, signal, green, red, orange. Very good. Okay, so now that we have that, let's go ahead and come back into this. So that's what jumpers are wires, but we have to remember that color code that we use. Now you're going to learn when we use those, okay, and you're going to learn what signal, power, and ground means, but just please reference that every time you go to use a wire. Make sure you're using the correct wire. Why do we use this? Well, it's not required by everyone else. It's required by me because you're in my class. But most people don't require different colors. But the reason I'm requiring it is because it's going to make the troubleshooting process 100% easier for me and for you and for anyone else you want to show on the web your circuit. If you're having issues with your circuit, and believe me, you will every time. I always do. Everybody does. It's the best thing to do is to go find someone who knows what they're talking about and ask them for help. You can't really do that if your circuit is a jumble of wires. Now, it may be a jumble of wires, and that's going to happen a lot because you can't neaten everything up. So that's where these color codes come in. If you've been color coding your wires the whole time, and you can tell them, hey, ground is green, red is power, and orange is signal, they're going to know exactly what to look for, and they're going to say, you have signal coming out of this place, but it really shouldn't be here. Move it to here. Or they could say, you have 5 volts going to this pin, but it shouldn't be here. Or, you forgot to ground this, all this kind of stuff. So they'll be able to help you as long as you have color-coded your circuits consistently. And that's why we went through that. Okay, so now we've talked about kind of setting up our circuit, getting it ready for these components. Now we're going to talk about the actual components themselves. So the first thing to talk about would be the LED, which stands for light emitting diode. In class, I talk about what a diode is. A diode pretty much is a component that allows electricity to flow in one direction only. If you try and send it the opposite direction, it's not going to go through, which means there is a positive side and a negative side. Okay, so to emphasize this fact, let me see if I can pull up my trusty notes. So what I have here, and I'm going to just increase this size because it's a little small, we have a long line. Now, on this side is the positive side, and on this side is our negative side. Now, this is our component. This whole thing here is our component, alright? And we can apply power here and expect to get it out here. But if we applied power here, we would not get power out on this side. There's a special word for this, and we call it polarized. So, meaning one side is negative or ground, and one side is positive or power, and you cannot cross the two. So if your LED is not working correctly, that's probably why. It is a type of diode, and it just happens to be a light emitting diode, but it's part of the diode class. So think about a diode when you're working with your LEDs. Okay, so LEDs, like we just said, are polarized because it's a type of diode, which means that only one side can receive power and only one side can be grounded. So the shorter lead is negative and the longer lead is positive. So see if you can I think you could memorize that. And let's see if you can, as we're doing these circuits, see if you can memorize, ground is the shorter and power is the longer. It's just going to make things a lot easier, okay? And you probably will have to refer back to your handout every time, but that's why it's there. For like a year or so of building circuits, you're going to probably want to refer back to that. But eventually you'll get to the point where you'll just have that memorized and you won't even need to look at that piece of paper anymore. Okay, So go ahead and write this down if you haven't already. Alright? Okay, so now let's talk about buttons. So the most important part about this button is that it has kind of an extra thing attached to it. So like we saw in the LED has a ground and a power lead. Well, this button is a little bit strange because it has a power and a ground, but it's a ground plus signal lead. Okay, now what is this signal? Well, what I want you to do is take a look at that button on the left, the lower left-hand corner, and you'll notice that one side is completely unattached from the other side, unless that button is pressed down. When that button is pressed down, that line connects the two circles together, okay, and electricity is allowed to flow from one end to the other. Okay, let's call the end on the left positive, which is our power, and we're going to call the lead on the right negative, which is our ground. So our ground is going to be both ground and signal. So here we get to define what signal is. So signal is the power that is coming out or going to something else. So that's what our signal is. Okay, so now that you know what a signal is, you're probably going to have a much better idea of what I was talking about with that orange wire being a signal. Okay, signal is the power coming out of a component. So the power going in is PWR, 5 volts. When we push that button, 5 volts is going to come back out of that button, and that power coming out on the negative side or the ground side is going to be our signal. Okay, so that's the idea behind our button. Okay, so now let's talk a little bit more about resistors. Earlier we said resistors we use to ground, we use resistors to ground components, okay? But what are resistors? Well, a resistor pretty much is, you saw a picture of it before. See if you can go back. You know what? I'm going to go back to where we had that picture just so I can show you what it looks like. That's a resistor. So if you want to look in your kits right now and find that, it's really, really small and it's straight out on both ends, but that's what it looks like up close. Okay, so that's what our resistor is. Now, what do they do? Well, first, we have to talk about different sizes. So there are actually, resistors come in all different sizes, okay? And pretty much we're just going to be using 3 different sizes in our projects. We're going to be using 330K, 10K, and 1K. You can look those up on Google, like 330K resistor, right? And 10K resistor, right? And 1K resistor, and you can look all those up and figure out what they are. Now the way to tell what they are is by looking at the bands. There are different colored bands on each one. It's actually, they're color coded. So by looking at those bands, you should be able to tell what resistance value of a resistor you have. Now, what is resistance? Essentially, resistance is the amount of electricity that the resistor allows to go through itself. So, like, you'd have to do some measurements, okay, but depending on the amount of resistance, that's how much electricity or voltage is going to go through that resistor. So 330K, 1K, and 10K are the 3 we're going to use, and you can pretty much just switch those out. At this level, we are just we're not going to get too far into how to do the calculations to figure out what types of resistors you're going to use, okay? I'm just telling you we're going to use those 3, and it doesn't matter which one you use. You'll find that some make your LEDs brighter than others, so you might want to stick with the ones that make the LEDs the brightest. Honestly, that part is up to you. Okay, so go ahead and experiment around a little bit with that and figure out which makes your LEDs look the brightest. Okay, let's talk about what potentiometers are. Potentiometers are also called a variable resistor. Now I much prefer that name because I like to think of a variable resistor as about 20 resistors packed into one little component. Okay, when you turn that knob, you're essentially switching out each resistor for a different one, either of higher or of lower resistance, meaning when you turn that knob, you're increasing or decreasing the amount of resistance that knob has. So it's going to allow more or less voltage through depending on what the resistance value is. So when you turn the knob, you're going to change the amount of voltage that is allowed to go through. Okay, so that's why I like the name variable resistor, because variable means change and resistor is, we just talked about, so change resistor or changeable resistor, which is really cool idea. It's a big fat resistor pack of resistors that you can just switch through. So it's got ground, signal, and power, and we talked about what all those are already. So I just wanted to make you aware of what a variable resistor or potentiometer is. We talked about that a lot more in class. Okay, so red, green, blue LEDs. So red, green, blue LEDs are pretty much like 3 LEDs all thrown into one. So you can make your LED either red, blue, or green, which is cool depending on which lead you apply power to. So if I applied power to the red lead, my light would be red. If I applied power to the blue, blue, and if I applied to green, it would be green, and so on. Okay, so that's how that works, and I would highly recommend writing this down. So pause the video now, go ahead and write this down, and I do want to point one thing out really quickly. The two ends are both the same length, okay, and then we have this one here, which is longer than every single one of them, and that's always going to be ground. It's the longest lead on the red, green, blue LED. Then we have one that is shorter than ground, but longer than these two end ones, so it's kind of in the middle, and that one is blue. So that's how you can tell the difference between them. Alright, so hopefully that helps you out a little bit with that. Okay, at this point you can actually take the quiz, and let's go through that process right now. You're going to take the quiz, not the final exam. So let's go piecrafters.com, and that is going to take you to the PieCrafters homepage once it loads here. Alright, great, and this is the PieCrafters homepage. I'm sure you've been here before, hopefully you have. We're going to go to the quizzes page, and you'll find all the quizzes you can possibly take. This is the quiz you need to take right now after watching this video, the electronics quiz. Okay, not the Arduino exam, not the Python exam, and definitely not the advanced quizzes or the advanced exam. Make sure that you take this electronics quiz. Okay, this will count towards your final grade, and it is important that you take this if you want your Arduino certificate. Okay, I hope you got a lot out of that class. I hope it wasn't too confusing, and I think you would understand it a little bit more if you had taken the class. Hopefully, though, I didn't throw too much at you at once. If you took the class in person, this is going to make a lot of sense, and it'll be a really good recap for you. If you didn't take it in person, you might be a little lost right now because I went pretty quickly through everything. So if you are lost, as usual, the Slack chat, you can comment under this video, you can send me an email, you can go to the PieCrafters website, go to the contact page, and ask me all your questions, okay? Do not feel like you are lost and can't get help, because I respond to messages, emails, everything very, very quickly, and I want to make sure that you are not, you know, going to just kind of quit because you don't know what's going on. Alright, so the next video we're actually going to build some circuits, which will be really cool. It's going to be an application video, which I know hopefully you guys like because they are a lot of fun. You get to do some hands-on stuff. There's a lot of switching back between this video and your actual circuit that you're building. You get to do something along with me, which is kind of fun. And so for next video you will need to make sure that you have your handouts, okay? All the stuff you wrote, all the notes from this video, which hopefully you were taking notes on each slide, right? And make sure that you have your Arduino Arduino kit with all your circuit components ready to go for the next recap session. Alright, hope to see everybody there, Good luck with your notes. If you didn't get enough notes, watch this video again. We will see you next week in the next recap video.